Factoring out greatest common factors. Remember, greatest common factors are the most robust common factors that are shared by two or more polynomials. For example, x squared and x cubed are monomials that share common factors. What is the greatest common factor of x squared and x cubed? Well, 1x and x squared are the factors of x squared. 1x, x squared, and x cubed are the factors of x cubed. The common factors are circled, and you can see the greatest one is x squared. True or false? Is 2x the greatest common factor of 6x squared and 2xy? Is 5x squared y the greatest common factor of 20x squared y and 30x squared y squared? Is 6xyz the greatest common factor of 18xy squared z cubed and 24x cubed yz? Alright, so for the first one, 6x squared and 2xy, we have 6, which is 1, 2, 3, and 6. Over here we just have 2, so that's 1 and 2, which means that the greatest common factor that's a number is going to be 2. And then for the x, we have x squared, which is going to be 1x and x squared. Over here we have 1 and x, just for the x here. So the greatest common factor between those is x. And here, y, we have 1 and y, but we don't have y over here. So yes, 2 times x is the greatest common factor. All right, let's move on to this one. 20x squared y and 30x squared y squared. So I'm going to quickly do the factors. We have 1, 2, 4, 5, so 6, 7, 8, 9, 10, and then 20. We have 1x and x squared, and we have 1 and y. Over here we have 30, which is 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 30. We have 1x and x squared. We have 1y and y squared. Okay, so now the greatest number between them both is 2. Oh wait, no, it's not. It's 5. Sorry, I missed that 5 there. Oh, no, it's not. It's 10. Look at that. So that's why this one's not the greatest common factor. So we actually have 10. And then we have x squared and y. So the answer is 10x squared y, not 5. Finally, I'm going to erase these. And we have 18x y squared z cubed, 24x cubed yz. Okay, so for 18, we have 1, 2, we have 3, 4, 5, 6, 7, 8, 9, and then 18. 24, we have 1, 2, 3, 4, 6, 8, 12, and 24. All right, we have x. Over here we have x squared, x cubed. Over here we have y and y squared. Over here we have just y. And then we have z squared, and z cubed. But over here we just have z. Okay, so the greatest is going to be 6. We have x, y, and z. 6, x, y, z. So the answer is true. Determine the greatest common factor and then factor out the greatest common factor to write the sum as an equivalent product of factors. All right, so in the first one, we have a greatest common factor of m squared n. And when you take that out, when you factor it out, what's left? Well, here, there's the 4. There's one more m, and we got the n. So really, we just have that 4m. Then from this term, we have the -7, we have, and just one more n. So we get m squared n times 4m minus 7n. The greatest common factor here is just 10, because see, there's no x in this last term, but each of these coefficients is divisible by 10. So we're going to factor out the 10. So basically that just means we're dividing each of these terms by 10 in writing that answer right here. So 100x to the 5th divided by 10 is 10x to the 5th, and so on. Down here, 1/2 x is the greatest common factor. When we take that out, we're dividing each term by 1/2 x. So what's left here? Just 1x. And when we have 1/2 x divided by 1/2 x, we get 1, but it's negative, so -1. To factor a mathematical expression means to rewrite a sum of two or more terms as an equivalent product of factors. So in example 1, 2x plus 10 is two terms, but we could turn it into one term by just factoring out that 2. 2 times x plus 5. Here we have 3 terms, which we can convert to just one term by factoring out the greatest common factor, which is 8xy squared. Note, terms are mathematical expressions separated by addition or subtraction signs, not in parentheses. So this is one term, 2 terms, 3 terms. And because these are multiplied together, then this counts as just one term. We are going to factor out the greatest common factor in order to write the sum as an equivalent product of factors. So 6x to the 4th minus 15x cubed plus 3x squared is a trinomial. So what is the greatest common factor? What is the trinomial factor? All right, the greatest common factor between these 3 terms is 3x squared. So if you take 3x squared out and then divide each term by 3x squared, you get 3x squared times 2x squared minus 5x plus 1. Recall that factors are integers that we multiply together to get an integer product. So remember, what are the factors of 6? Any numbers that are multiplied together and you get 6 at the end are factors of 6. So 2 times 3, -2 times -3, 1 times 6, and -1 and -6. Therefore, plus and minus 1, 2, 3, and 6 are the factors of 6. Factoring negative integers is a skill to develop. True or false? -2 times x minus y equals -2x minus 2y. This is false because -2 times -y is going to give us plus 2y. So this is false. Those two negative signs would cancel out. -5ab minus 15, that is true. -20x minus 10y. All right, well, let's multiply it in reverse. So -20x, yes, minus 10y, yes, that is true. Okay, -2m squared plus, see that negative sign and that negative sign are going to cancel out, give us 2mn squared. This should be a plus sign, therefore this one is false. Here are the answers. This is false, this is true, and this is false. Two numbers are additive inverses, or opposites, if and only if the sum of the numbers is 0. -2x plus y and 2x minus y are additive inverses because if you add them together, you get 0. What is the opposite of these binomials? All right, so you just switch the sign. -3x plus 1. So if you added those together, 3x minus 3x would give you 0. -1 plus 1 would give you 0. So this would be -5a minus 3b, -x minus y, and -4x plus 6y. Every time you add a binomial to its additive inverse, you end up with a sum of 0.